Alright, let's take a look at the freefall worksheet. I don't have the problems to show you, so I'm just going to read them to you, and you guys should look along on yours. Number 1. Will you ever use the equation v equals d over 2 in freefall problems? No. Why? Because v equals d over t talks about velocity, but only talks about one velocity. In freefall problems, our velocity is always changing because we're accelerating. So in freefall problems, we're always going to use formulas that have acceleration in them. Okay, so you're always going to have an a term. Number 2. What is the acceleration for any freefall problem on Earth? That's the number I told you guys. It's going to be the same for any object, regardless of weight. And that's if you're ignoring air resistance. That is negative 9.8 meters per second squared. Okay, number 3. Zarya bungee jumps off a bridge and free falls for 5 seconds before the cord slows her down. Part A says, how far has she fallen in those 5 seconds? Okay, so what do we know? Well, since this is a free fall problem, we know one thing off the bat. Acceleration is going to be equal to negative 9.8 meters per second squared. What else do we know? Well, her initial velocity, what was that? It was 0. Unless somebody threw her down. When she stepped off the bridge, she started out going 0 meters per second down. Okay. And so then the problem says she free falls for 5 seconds. So my t is going to equal 5 seconds. And then I'm trying to find out how far she fell. So my d is what I'm looking for. So we're going back to our handy dandy sheet over here. The formula sheet tells us what formulas to use. And this one looks like the one to use right now. Because I'm looking for D, and I know this stuff. So I can use this one and it'll give me the answer. So my displacement is equal to my initial velocity times time plus 1/2 times my acceleration times time squared. Let's see. So I plug in what I know. Well, I know my initial velocity is 0 meters per second. So I plug that in. My time is 5 seconds. And then plus 1/2 times negative 9.8 meters per second squared times 5 seconds. And this is squared. So this first term just ends up being 0. Then I gotta get out my calculator to do this next part. Alright, so I got negative 122.5 meters. Okay, so that was number 3. Let's look at number 4. Oh, sorry, there's a part B to number 3. Let's talk about that. How fast was Zarya going after 5 seconds? So in this first problem, we had an initial velocity, and that was 0. And we solved for how far she went. She went 100 or negative 122.5 meters. But we don't know what her final velocity was, so let's look at our sheet. So we're going to be looking for final velocity. And we have our initial velocity, and we have acceleration, and we have time. This looks like the one. So VF equals VI plus AT. Or my final velocity is equal to my initial velocity plus acceleration times time. So my initial velocity, we said last time, is going to be 0 meters per second. My acceleration, well, that's always the same in free fall problems. It's negative 9.8 meters per second squared. And then times my time, 5 seconds. Okay, plug it into my calculator. Get 9.8 times 5. We get this should be equal to negative 49. What was it, seconds? Meters per second. Okay, moving on to number 4. Pippin knocks a bucket down an empty well. He counts 7.2 seconds before the bucket hits the bottom. How deep was the well? Alright, so Pippin knocks down an empty bucket down a well. 7.2 seconds before it hits the bottom. How deep was the well? Alright, well, in my free fall problems, what's my acceleration always equal to? Negative 9.8 meters per second squared. And in most cases, at least in every case we've seen so far, my initial velocity is going to be 0 meters per second. Right? Because when the bucket started falling, it started out going 0 meters per second. At least in the vertical direction. Okay, what else do we know? He counts 7.2 seconds before the bucket hits the bottom. So that tells me that my time is equal to 7.2 seconds. And then we're supposed to find out how deep is the well. So how deep, that's how far, how long. That's going to be displacement. So I'm trying to find out what the displacement is, or the distance. It looks like we're going to use this one again. So my displacement is equal to my initial velocity times time plus 1/2 acceleration times time squared. Alright, well my initial velocity is 0 again, so I'm just going to write 0 here this time. Plus 1/2 times my acceleration, negative 9.8 meters per second squared, times my time squared, and that was 7.2 seconds. All of that squared. So I get out my calculator again. Say Alright, I'm going to do that again just to make sure I got the right answer. You guys do it too. 7.2 squared times 9.8, or negative 9.8. Yeah, okay. Works out. So my displacement is going to be negative 254 meters. Alright. So let's go on to number 5. Number 5. Mitchell drops a penny from a skyscraper 500 meters in the air. How long in time does it take the penny to fall to the ground? So what do we know? Well, since it's a free fall problem, we're going to start out knowing our acceleration, right? It's always the same, negative 9.8 meters per second squared. What else do we know? What was the velocity when he dropped the penny? The initial velocity, 0 meters per second. It says also that it fell from a height of 500 meters. So what variable is that going to be? That's going to be my distance or displacement. And since the penny fell down, and I know that down is negative in these problems, I'm going to say that my d is equal to negative 500 meters. Again, that's because displacement is a vector, and so is acceleration. So if they're both pointing down, they're both going to have a negative sign. And they are both pointing down in this problem. So the question is, how long does it take the penny to fall to the ground? So we're going to try and solve for t. Let's see. So nothing up here is like really jumping out at me. I could use this formula to solve for t, but actually they've already done that for you on this formula sheet. You just use this instead. Okay, so your time is going to be equal to the square root of this whole thing. And this says 2 times my displacement. You can ignore this little y right now. So 2 times my displacement divided by g. And g is just this 9.8 number we were talking about. It's my acceleration due to gravity. So let me write this on my sheet. T equals the square root of 2 times d divided by my acceleration due to gravity. And so what do I come up with? I plug in 2 times negative 500 divided by negative 9.8 meters per second squared. I get out my calculator again. 1,000 divided by 9.8. I need to take the square root of that. Okay. So my answer, again, I did 2 times 500 is 1,000 divided by 9.8, and I get some number, and I take the square root of that number, and I get 10.1 seconds as my time.